All right, let's start. So, thank you very much for coming to my talk. It's a pleasure to see so many people in the room, and we'll talk about shared libraries. By the way, I didn't use any AI when I was preparing to this presentation, so I hope you appreciate that. And I would like to start with what you won't learn today, all right? So you won't learn how to implement a common library in your team, because everybody has their own context and setup. However, I'll be happy if you get some useful insights, maybe a couple of them, of some ideas, and maybe you can bring them to your work and use at your work. So shortly about me, I'm actually run training in Spring Boot, architecture, domain-driven design, TDD, and other things. My name is Vadzim. I'm a co-owner and instructor at Training Tech, where we run all of those training, and I work as well as a hands-on architect at Apotek One. Apotek One is the biggest pharmacy chain in Norway. And a couple of facts about my private life. I have a family, and I'm so happy that my wife is here in this room with me. Since I live in Norway, so I have no choice. I enjoy nature, skiing, fishing. I like playing the guitar and singing, so I have kind of a backup plan. If AI takes my job, I'll play the guitar in restaurants. I like working out. I love cars and making goodies for my family. So my motivation before this talk was that I actually implemented a shared library in my organization that has been successfully used for 3 years by multiple projects, and I saw different approaches during my career and at some conferences, and sometimes I thought like maybe I could do it a bit better. That's why I came here just to share some of my ideas. I've been using Spring for almost 20 years. Yeah, I'm not that young anymore. And I would just, to share my experience with you. So today we will address when we need to share our code, because maybe you don't have to. What not to put into share code, because sometimes we are so eager to put a lot of stuff there. We'll go through the structure of the library we built at Apotek One. Below topic documentation, I know everybody is excited about it, making changes, and we'll talk about how to promote the library among the projects. So let's start with when we need to share our code. And so this is not like taken from any books or articles. This is totally based on my experience and my painful mistakes, actually. So 4 things that I think you should have if you want to share the code among different projects. So first of all, you should have, when you have multiple projects that solve the same technical problems. All right. If you have only one, probably you don't need to start with sharing the code. And you're tired of copy-pasting the same solutions across projects. So you implemented something here, implemented something there, then you found a bug there, you go and fix it here, you go back and fix it in other projects, so you're kind of tired of it, and that's why maybe you want to share the code. And the shared code costs less than repeating it. So maybe in your case, it's okay to repeat it. Maybe all the products or projects want to go their own way. Maybe they don't want to, let's say, synchronize with one source of truth and just adjust to the versions, run some migrations and things like that. Maybe it's just fine. And people agree to use standardized approaches, because if you, let's say, force them and they don't agree, so formally they will use your library, but in the reality there will be a lot of kind of black market. Yeah, so all right, so I think if you have 4 of those, then you're good to go. If you have only 3, 2, 1, you should think about it. And I did some of mistakes myself, and I can say that When you don't have any of those four, then it's just it can be harder. All right, so now let's talk about what not to put into the shared code. Do you have any ideas what not to put? Yes? Log4j configuration, yes. We remember our log shell, yes? Secrets. Anything else? Okay, so the first thing I would like to talk about is the business logic. Let's say you have one project that maybe has a product, another one has product, and then you have this brilliant idea. Let's create an abstract product and put it in the shared place. And add a bit of like a little business code there, business logic, because everybody shares this business logic. And I would like just to, you should notice this weird sound, like it's you opening a Pandora box, all right? Because it will bloat, it will never stop. And there will be one more use case just appear at some time when people will tell you that, okay, actually we don't need this business logic, so let's add if. Okay, and just of course there are some exceptions, and maybe you have this exception. However, I think this exception just proves the rule. All right, so please don't put business logic in the shared place until you kind of you know what you are doing. Next thing is unstable features. So when you create a shared library, you have a so-called like a trust capital given by other people. And if you release some feature which has a bug, okay, they will create a bug. So we as developers, we write buggy code, no problem. But if you create the second one, third one, fourth one, then you will just miss this trust, all right? And people will be reluctant to use your share code. So in the share code, only like a well-tested, high-quality code should go there. The next one, expectations. Like you expect that it will be useful for someone. And what usually happens? Nobody uses it. Nobody needs it. Okay? You put this code, and you may think, all right, but yes, I put it, but it's just it's for free. It doesn't have any costs. Does it have costs? You need to maintain it, yes? You upgrade to newer versions of frameworks, so you need to migrate your code. You need to support it. Maybe fix some bugs as well, right? So it's not for free. That's why just hold on with your expectations. And the fourth one is your ego and desire to help. Some of us would like to show off. Some of us would like to contribute a lot. I will just write as much code for my colleagues as I can. Some of us maybe want to write their own first framework in their life. I think that every developer should try to write their own framework, because this is where you learn the things. What works, what doesn't. However, probably the shared library used by many projects shouldn't be this like a sort of a battlefield, experimenting with your own framework. Okay, so the less code you have, the better, because it's less maintenance. So now let's slowly go to the specific example how we implemented shared libraries in our company in Apotek 1. And I would like to start with some rationale, so you will understand a bit about our decision. So first of all, we wanted that libraries should be easy to use, ideally by just adding a Maven dependency. So you just add Maven dependency, and this is all you need. Next one, developers shouldn't be bothered by configuration of the library. I'm just curious, anybody here, like how many of you worked with Spring XML configurations? Okay, yeah, pretty many people. It was like another life, yes? You just scrolling, beans, properties. Yeah, I remember that. Yeah, the times. Never go back. So we shouldn't. Developers shouldn't be bothered by long configurations. The next one, it should be possible to use only specific features. So they can just choose. And in our case, we have a number of on-prem projects. So they can't just, be thrown on that new library. They want to gradually migrate to that library. So, okay, so today I pick, for example, observability. In maybe next month we'll pick maybe some CQRS or something like that. So just we had to make it possible for developers. The library structure should follow and provide some guidelines, which means that it should every module of the library should look familiar. There shouldn't be completely different implementations inside the library. And our code doesn't always depend on Spring Framework. So we don't want to always depend on some infrastructure related stuff, and we wanted to have our own simple abstractions as well. So the root level looks like so in our case, and in your case it may look differently. As you can see, we have only technical concerns, no business logic there. And yeah, this is just an example. And if you go to the root pom.xml file, it consists of the following. Yeah, by the way, the name of the library is JavaLibs. So sometimes I will say JavaLibs because I'm just used to it. So first part is properties, where we have like a shared properties like GDK version, dependency versions, just everything is put there. The next one is plugin management, where we define default configurations for plugins. In our case, we use spokes, so we just define that. Okay, so every module, when we build every module, all the spec files will be processed. Plugins, like a default plugins to run. As we use spoke, we need Gmaven plus and just for Groovy compilation and check style. So it was our choice. Those plugins will be run by default. And dependencies with their versions, like a dependency management. I hope all of you are familiar with dependency management, right? So it means that if in a module you need some dependency, you don't have to specify the version of it. You just specify the group ID and artifact ID. And some dependencies, default dependencies. No log4j, only lombok and logback in our case. Okay, so now we go to the module level, and I would like to present you like a concept. So I read some Spring documentation, I investigated Spring sources, I investigated different library sources, and we kind of ended up with the following concept. So how we want to structure it. First of all, we would like to have a module with the suffix core. Core just is a handful of classes, nothing else, where we don't depend on Spring framework, and we have just our own abstractions. Then the next module has a suffix Spring, which is actually implementations with the help of Spring framework, like extending those, implementing those abstractions, and being dependent on Spring. Next one, Spring Boot auto-configure, contains only auto-configuration classes and properties. And the Spring Boot Starter, which provides default set of dependencies. It's a kind of tiny module. If you ever looked at the Spring Boot Starter, usually it consists of like kind of two files, maybe pom.xml and what else? Yeah, module file. So then we realized that actually Spring and Spring Boot auto-configure can be one module. You can think about it as well. So maybe you can just put it in one module, and it doesn't matter to split it into two modules. Okay, so example, I chose CQS. we have core with a handful of abstractions, like a command query, command gateway, Spring, implementation of it, auto-configure, auto-configuration class, Spring Boot starter, default set of dependencies. You just include it in your project and you just run it. And as well, like a Spring test, which is not required, but sometimes you want to give a support to your client project to write tests when you use your library. It's just test support classes. POM XML and README, of course. Now, if we go on the like a sub-module level, okay, so we were on the module, now we go to sub-module. In this case, I chose observability. So the core contains just four files, nothing else, like one interface, a couple of classes. Then Spring contains implementations related to those abstractions. Then next module, which depends on the Spring, is the Spring Boot auto-configure, where we have default auto-config, micrometer auto-config. So as you see, over here we have a choice. So you can choose which one you need. And it's very important when you put dependencies in your POM XML of your auto-configuration, it should be optional. Because depending on the choice, you don't want to bring all the dependencies with your auto-configure module. In some cases, a client project may choose micrometer. In other case, maybe something else. Or maybe just default implementation that don't have and just generates, for example, trace ID, a new trace ID all the time, for example. Right? So those dependencies should be optional. Was it clear enough? All right, good. And the Spring Boot starter. Okay, so it was these two files, POM XML and README. So the Spring Boot starter contains a set of dependencies which will be used by default. So whenever you depend on Spring Boot starter, you will have this Spring Starter actuator, micrometer tracing, and micrometer tracing rich OpenTelemetry. All right, and if you have multiple permutations of different dependencies, so it should be visible in the name of the module. Instead of Spring Boot starter, you may have some, let's say, micrometer Spring Boot starter or something like that. All right. In our case, we have only one. That's why we just call it Spring Boot starter. And for client projects, isn't just enough to depend on this Spring Boot starter without any configuration. Now let's talk about auto configurations, because as just based on my experience, not everybody like a query understands how these things works. Auto configurations. So first of all, please I would like to just mention on the auto configuration annotation, right? Because we have configuration and auto configuration. If you create auto configuration, so you should use this auto configuration annotation. And the difference is that when you use a configuration, and for example, you wanna service A to depend on the service B, the Spring, by calling the local method, Spring will do the magic for you. Spring will create a proxy, and when you call a local method, it will just return you all the time the same shared instance of the bin. Okay? If you use auto configuration, no proxying will take place. In this case, you need to specify dependency as a parameter to the method that creates your bin. This is the main difference. So why should we use auto configuration? Only one reason: the speed. No proxying means faster. Of course, if you have one or two auto configurations, you won't notice any difference. But however, it's just idiomatically correct to use auto configuration. So maybe you will have more classes, then you just save. So one more thing that you should use is conditional annotation. Okay, that's kind of important as well, because you want to create beans only if they are not already presented in the application context. We have kind of rule in our library, like all the beans existing in all auto configurations should have conditional annotation. So we just make it sure that this bean will be created only if you don't declare the same bean in your client project. So the concept of overriding beans as well, like nice to know actually. First of all, we have auto configurations that will provide you default bean instances if you don't declare any beans in your client project. If you declared anything in your application production code, then those instances will be used, not the auto-configured ones. And you have one more level, which is your test code. And here you can create the same instances by using primary annotation. This is what we used like for 3 years. And 3 years ago, it just worked fine. I will show you like one more flavor that you can use as well with the newest version of the Spring. But this is like a concept. In my opinion, it should be like a put kind of by default or considered by default in many places. So auto configurations, if nothing exists, then your application production code, you just don't bother with any annotations, primary, just nothing, you just declare it. And in test code, if you want to override it application-wide. And you as well should make sure that your auto configurations runs after ordinary configurations. Just please don't forget about adding your classes to the meta-inf Spring file. Have you heard about fallback annotation? Just some of you, because it's a pretty new one. The idea is that you can as well use a fallback annotation, which will and Spring will instantiate that bean if no other bean is found in the application context. As I remember, it has even lower precedence than the order annotation with the lowest priority. Yeah. So just if no bean is found, the fallback bean will be used. And some of you may think, oh, but maybe I can use this in my auto configurations because it just looks similar. I would say that technically yes. However, this is not like idiomatically correct. So if you use auto configurations, so you should use the conditional annotation, and the fallback can work, for example, when you have multi-module module setup in your project. So you just define in some like default, let's say, place, you defined all the fallbacks, and in some module you can just define the same bean without any primary annotation. In my case, I've never had the need for the fallback annotation, but many people had. So if you have any ideas, so maybe come to me after my talk and explain me like why you need it. I don't know. Still, like I can live without it. And one more is a test bean, which allows you to redefine your bean in your tests in when your scope is the test class, not application wide, but only test class. So you can create just a static method and redefine your bean, and this bean will be picked by Spring Framework. Okay. The next one is the code quality. As you remember, I mentioned unstable features, so we would like to have a good code quality. So and ideally automatically verified. So what did we do? We actually employed some tools like an editor config for common formatting. So you just commit one file .editor config, and you don't need to bother with your settings of your IDE, so every developer has the same setup regarding the formatting. It's kind of great tool, and very simple, and IDEs has integration with it. Check style and error prone, it was our choice. Previously we used Sonar Cloud as well, then we abandoned it because it just for the given price it didn't give us too many benefits. However, I'm not saying that this is a bad tool, so this is a very good tool. And ArcUnit, are you familiar with ArcUnit? Okay, quite many hands. When I ask in .NET developers, it usually just a couple of hands. And Sneak for automated vulnerability scans works really great for us. Just we are happy. So ArcUnit example, if you're not familiar with that, you can just describe in almost plain English what you want from your structure, or maybe you can let's say introduce some rules in your code bases. In this case, we have like a methods that are annotated with beans and declared in classes that are annotated with auto configuration should be meta annotated with conditional class. As you remember, I mentioned the rule that we should have conditional class on all the beans in auto configurations. We didn't want to check it manually when reviewing PRs. So instead, it just this tool can automatically run. And as you can see, it works like as a documentation as well, kind of dynamic documentation, because you can add as the name for the rule, and you can add as well because, where you can explain why, and you can as well put links to, for example, Confluence. It's just amazing. It's my beloved tool, and I kind of can't imagine myself working on any project without ArcUnit. It's just big time saver, all right, and great tool for knowledge sharing as well. One more example, very simple. Controllers are annotated with OpenAPI annotations. We just don't forget to put tags on the controllers. Or code is free of package cycles. Anybody has package cycles? You have. Yeah. So if you put it like from the start, because the package cycles, what does it mean? They just show that potentially you have issues with your design. Maybe it's okay, but potentially you have issues. Yeah, and we have code which is free of package cycles everywhere. So in the library and in the client projects. And how do we use this ArcUnit? In the client project, we have just a simple architecture test, and we just specify you will comply with standard test, code is free of cycles, Spring test, DDD test, and we have many of them. And each ArcUnit setup consists of 50 lines of code, 100 lines of code. Like those are small classes, but helps a lot. Now the kind of the most favorite topic, because everybody likes reading 10 pages long documents, right? So I'll try to run it real quick. What I would like to say about the documentation. So first of all, make sure people can find it. If you find yourself in a situation when you send links to your Git repos, to README files, to different developers, then I think you have a room for improvement. All right? What I mean is that you should have maybe multiple or several entry points to your documentation. Maybe one entry point in Confluence with the link to your README file. Another entry point is actually a README file, so people can just find your documentation from different places. Okay, not only README file. To dry or not to dry in the documentation. So my choice is not to dry. If you follow dry in the documentation, then it will be just again harder to find the information. Sometimes you need cross links, and a bit duplicated information, maybe duplicated examples. Yes, it's more maintenance. However, people will be just happier when they use your documentation. Yeah, that's the price, and I'm kind of we are kind of okay to pay this price. README files. So first of all, make sure people can navigate through multiple README files. So if you have several modules, they shouldn't be like, oh, I want to read about this module. Okay, I need to let's say expand it, find README file. Okay, I need to read about something else. I need to find it in the structure, and then I go to this README file. So supply your README files with links, and those links should work. Okay, so they just click, go back, so they can navigate in a convenient way. The next one, imagine that your documentation is read by junior developers. And what I mean here is that we shouldn't assume too much about the knowledge of our colleagues. When we say, like in our documentation, like step number 5, authorize in a system XYZ. Maybe this person sees that system for the first time in their life. How to do that? Okay? Just assume that, okay, so they can run some commands, they know where our Confluence exists, and something like that. So those assumptions just may take place. However, other assumptions, like a deeper understanding, should be avoided. So let's imagine the junior developer reads your documentation. And this will provide some examples and guidelines. It shouldn't be perfect, like a documentation for your open source framework, like a Spring, for example. So they have people who actually spent a lot of time writing documentation. However, it should be just convenient enough. Just be kind of pragmatic. Seek for the balance. Next one, making changes. What if we need to make changes in our library? So first of all, making changes should be straightforward for contributors. All right, so usually we want to attract contributors and not work alone on our libraries, yes, which means that if you have 20 or 25 steps of doing a release of your shared libraries, so this is the perfect way to work on the shared library alone. Okay, perfect way. It's just anybody just take a look at it and then decide, oh no, I want to contribute. So your documentation should be, or guidelines should be very, very straightforward. As well, it happened a couple of weeks ago. One developer tried to release a library, and he made a mistake in versioning. And I asked him, could you please read this contributor guideline, because it describes how to release it. He read it again and did a mistake again. So instead of being irritated, I made the conclusion that the problem was with me, who wrote this guideline. All right? So I went to the guideline, fixed it, and we ran it again. One good practice that I use among developers, and maybe you know, what is the perfect way of verifying your guideline? What is the perfect way? Or one of the best ways? Huh? Yeah. I heard it like do it yourself, without my explanations, without oral help. When you're sitting together with developers, okay, now we will run my guideline, and you just go to this to all of the steps. Do it yourself. This is how you can check the quality. Thank you. Yes. So if it happens, they can't follow it. It's kind of your mistake, not theirs. Versioning. We actually kind of follow the semantic versioning, and we use major versions for big migrations, like from GDK 17 to 21, or upgrading Spring framework, their major versions, things like that. So we use major versions for that. However, we don't we are not we don't comply with the minor versioning guidelines, because sometimes we use minor versioning where like a little migration is required as well. Because otherwise we would have a very high major version, like a Java Libs version, I don't know, 30, for example, which kind of looks a bit weird, yes. So sometimes we use minor versions where a little migration is required, and we are fine with that. However, it doesn't mean that you should do the same, but it works for us. And patch versions just automatically set by CI/CD to build ID, so we can just clearly match what version was built and where, and just go and follow the artifacts, the log, and things like that. When we want to documenting our changes, we chose a changelog file. You can just check the link. I will provide you QR code at the end as well to the presentation slides, and which works for us just fine. We write them manually, and with the help of AI, it takes too little time, and it just works without any problem. We don't need to maintain any tool, any library, migrate to it. So it's just simple file that shows what we are doing. Okay, supporting old versions, which as well can be a choice for you, right? Because you may choose. All right, so we migrated from one major version to another one. Should we create a new branch and support that old version, because some projects are still using that old major version? And in our case, the answer was that we don't want it. We just don't want to support multiple versions. Instead, we constantly upgrade client projects. What helps us, or what forces us, is that we have a company policy. So whenever Sneak sends us a report with a critical vulnerability, so we are obliged to migrate it to all newer versions, which means that all the projects are always like up to date. The result, simplicity at the given capacity. Okay, so that's what works for us. So sometimes you don't need to kind of overcomplicate the things. Okay, so if let's say we have done the change, should we just ship it? Build works great, just tests are fine. In our case, we decided that no, successful build is not enough, and we created a couple of reference projects. One just single module, single Spring module, another one Spring multi-module. That depends on these Java libs, and when we make a change, we build those projects as well, and we run them as well, and check that everything is still fine. Sometimes, because sometimes it's not. Kind of, they just show how it will work in real life, and sometimes they detect a couple of issues for us as well. Next one, reproducible builds. This is an anti-pattern, yes? No? Yes? Yes, it's an anti-pattern. We use version range, so which means that all the, like, if we have a new patch version, then with each build, the newer patch version will be used. However, in our case, it's totally fine. We don't have any problems with that. Just during those 3 years, maybe we got one problem once. So yesterday I tried to kind of recall, have we gotten any problem? And we haven't. Maybe in your case you will have, but by using this like an arc unit, applying all of this test quality, reference projects, it works better. Because at our capacity, because we are not that big team, it would cost much more, like for every change, to go to all the projects and fix the specific dependencies there. So in our case, it's just much better to use this approach. Okay? I like to say be pragmatic, not dogmatic. And the last one, forcing or advertising. And what to choose? Should we force others to use our library, or should we advertise it? In some cases, in some environments, maybe corporate environments, I don't mind forcing people. However, what I prefer, even I work in a corporate environment, I prefer advertising things. Like you run maybe some knowledge sharing sessions. You just there appeared some some rumors about, okay, that actually library was fine. We like using it, and people just start using it more often. However, if you force it, just be prepared for like a couple of consequences. So if you advertise it, you can verify the quality and demand for share code. If you force it, you can't verify it because people are forced. And you may live in the illusion of a good job done. Anybody's working in corporate environments? Do you? Oh, okay. Do you have a kind of sort of black market? Which means that there are policies, people say that they're compliant, managers report that we use it. In the real life, there are private chats. You know whom to ask to do a favor for you. Familiar situation? Right. So you will force the people. You will live in the illusion of a good job done. However, people kind of formally will use it. Maybe even will depend on it, but they will for sure find a way and the workaround. So they will be listed in the Maven dependency, but they will just somehow override it, exclude all the beans, and use their own implementation. Okay, so I'm for advertising. So conclusions for today: make sure you need the shared library. So because maybe you don't need it. Please remember those 4 things. Don't include anything unnecessary. The more code, the more maintenance, and it's really hard for developers. It's really hard for myself. I'm asking myself like a minimum 3 times if I will put this new code into the shared place, because I like contribute so much to my company as a hands-on architect, right? Create a stable and understandable structure so people can follow it and understand. In our case, it's pretty stable with those 4 modules, like a core, Spring, auto-configure, and Spring Boot Starter. Help people navigate and contribute via well-written documentation as well, because without the documentation, it will be so hard to use your library. We had as well a situation when we had like an internal product, but since people didn't know how to use it, they just kind of protested a bit. All right, so the documentation should be quite good. Choose the easiest versioning strategy that works for you. Don't be bothered by those supporting multiple versions and just adding some accidental complexity that is not required. And if people want to use it, you have done a good job. If they want to use it. Thank you very much. The link to the slides. Thank you. You can contact me as well, and I will upload presentation slides today. Okay, so you can just save the link, and it will appear today. So if you have any questions, come to me, or maybe you can ask. Yes.